x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Alright, so we're going to look and talk about matrix operations. Matrix operations, we have addition, subtraction, and multiplication. You actually can't divide a matrix. So we're going to talk about the simple operations. We're not going to talk about multiplication today. So the entries in a square matrix located in row I, column J, where I equals J is said to be a main diagonal, top left corner to the bottom right corner. So what that means is if I have a matrix like A3, matrix A has the dimensions 3 by 3, or if matrix B has the dimensions 4, or let's say 5 by 5, could be 4 by 4 as well. That means that there's a main diagonal, and on that diagonal is an element from each row and each column. So top left corner to bottom right corner is what the diagonal is. A square matrix, S, with dimensions n by n, is symmetric if all the items, right, that are flipped over the diagonal are the same. So as you can see in this one, they're asking the elements of the main diagonal for k and are 2, 0, 2, 7, 2, 8, 1, 5, 7, 5, 4. But if you'll notice, these two are reflected, they're symmetric. These two are symmetric, and those are symmetric, they're the same on either side of the diagonal. So this matrix is a symmetric matrix. It doesn't have anything to do with the diagonal, it has to do with the things on either side of the diagonal. As we can notice here, these seem to be the same, and they are the same as well. So in this, this matrix L also is symmetric. So 7 is the same as 7, negative 1 is the same as negative 1, 4 and 4, 8 and 8, 4 and 4, negative 2 and negative 2. So those matrices are symmetric. Alright, matrix addition and subtraction. So addition and subtraction. So when we're adding and subtracting matrices, we are going to make sure, first of all, that they have the same dimensions. If they don't have the same dimensions, we can't add them or subtract them. So we either have a solution or we don't. This is a 2 by 2 matrix, this is a 2 by 2 matrix. Since they have the same dimensions, we can add them. And the easy way to do this is add the corresponding elements. So in this case, I would add the 2 and the 7. So there is a solution here, and we're going to work it out. So 2 plus 7 is 9. 4 plus negative 8 is negative 4. Negative 3 plus negative 1 is also negative 4. And 5 and 2 adds to 7. And so I can add those, and that's what the matrices would add to. The dimensions here has, this is row 1, row 2, column 1, column 2, column 3. This is row 1, row 2, row 3. So we see that this is a 2 by 3. This is column 1 and column 2. This is a 3 by 2. And so these don't match. So there is not a solution there. We cannot add those matrices together. The dimensions over here, this is a 2 by 3, and this is a 2 by 2. Not the same dimensions, so we cannot add those. And this is a 3 by 2, and this is a 3 by 2. So there is a solution, and I'll let you add that together for yourselves. Given the dimensions information, which operations are possible? So if we have matrix A is 3 by 2, matrix B is 3 by 2, and I want to add the matrices, can I do it? Yes or no? And the answer is, yeah. They have the same dimensions. If they have the same dimensions, I can add them. When I add them, they will, so yes, they will have the same dimensions as the original, 3 by 2. I'll let you work those out on your own.